Hey everyone, and welcome. Today, we're going to dig into something that seems super simple on the surface, numbers in Python. But trust me, there's a lot going on under the hood. You ready to see how Python handles everything from just, basic counting all the way to complex physics? Awesome. Let's get into it.
So let me kick things off with a question for you. Have you ever been coding in Python and wondered, why is 1 treated completely differently from 1.0? I mean, to us, they're the same value, right? But for Python, they're not the same thing at all. They're like worlds apart. Stick with me, and by the end of this, you'll get exactly why that is.
Okay, so to really understand that, we've got to open up what I like to call Python's numeric toolbox. Seriously, think about it like this. A programmer needs different kinds of tools for different kinds of numbers. It's just like a carpenter, right? You've got different tools for different jobs. You're not going to use a giant sledgehammer to hang a tiny picture frame, are you?
And inside this toolbox, Python gives us 3 main tools to work with. First up, you've got the int. This is our solid, reliable hammer. Then, there's the float. That's our super precise measuring tape. And last, we've got the complex number, which is kind of like a high-tech laser level for those really specific, advanced jobs.
All right, let's grab our first tool, the hammer. That's the integer, or as we all call it, int. This is your absolute go-to for anything that's a solid, whole number. You know, things like counting items in the list, tracking how many steps you've walked, or numbering pages in a document. Yep, that's a job for an integer. So, what exactly is an integer? Well, it's pretty simple. It's any whole number. It can be positive, it can be negative, but here's the key. It absolutely, positively cannot have a decimal point. And here's something that's really cool and honestly super powerful about Python. These integers can be of unlimited length. Seriously, as big as you need them to be.
And this right here, this shows that power perfectly. Take a look at these examples. So x is just 1, simple enough. But then look at y. That is a massive number. In a lot of other programming languages, a number that big would cause all sorts of problems. But for Python, no big deal. Same with z, a big negative number. Python's int just handles all of them, easy peasy.
Okay, let's put the hammer down and pick up our next tool, the float. Now, if an integer is for counting whole things, the float is all about measuring things with precision. This is our measuring tape. It's for all those times when close enough just won't cut it, and you absolutely need those decimal points. So a float, or a floating point number, is just a number, positive or negative, that has 1 or more decimals. And hey, this brings us right back to that question from the beginning. The number 1 is an int, our hammer, but 1.0, just because it has that decimal point, is a float, our measuring tape. And that difference is so important in programming. It's really all about precision. Integers are for perfect, exact counts. Floats, on the other hand, are for measurements that need that decimal, and the way computers store them is as super close approximations. Let's check out the code to see what I mean. So x is 1.10, z is negative 35.59. Okay, those are obviously floats. But look closely at y equals 1.0. Even though its value is just 1, that little .0 is a huge signal to Python. It's basically saying, hey, treat me like a float. I need that decimal precision. And another really cool thing about floats is they can handle gigantic or super tiny numbers using what's called scientific notation. That's what you're seeing with that little e on the screen. It's just a shortcut for times 10 to the power of. So 35e3 is really just 35 times 10 to the power of 3, which is 35,000. This is an absolute game changer in fields like science and engineering.
All right, now it's time for our most specialized tool, the one you don't pull out of the toolbox every day. This is the complex number. Think of it as our laser level. You're probably not going to need it for simple projects, but when you get into things like advanced math or electrical engineering or even quantum physics, well, then it becomes totally essential.
So, complex numbers have 2 parts, a real part and an imaginary part. Now, if you remember from math class, you probably used the letter I for the imaginary part. But in Python, and actually in a lot of engineering fields, we use a J instead. Don't let that throw you off. It's just the way Python marks which part is the imaginary component.
And here you can see exactly how it works. The variable x has a real part, which is 3, and an imaginary part, the 5j. But what's cool is you don't always need both. If you look at y and z, you can see it's totally possible to have a complex number that's only an imaginary part.
Okay, so we've got our hammer, our measuring tape, and our laser level. But what happens when you start a job with one tool and then realize, oops, I actually need a different one? Well, the good news is Python is super flexible. It lets you convert or cast between these different number types.
And it's actually really straightforward. You can use the float function to turn an integer into a float. It just slaps a .0 on the end. And you can go the other way using int. But you gotta be careful here. When you change a float, say 2.8, into an integer, Python doesn't round it up to 3. Nope. It just chops off everything after the decimal, leaving you with 2. So you actually lose some information there. And yeah, you can also convert numbers into complex types too.
And this is a really important rule to remember. It's a one-way street when it comes to complex numbers. You can turn an int or a float into a complex number, no problem. But you can't go the other way. You can't convert a complex number back into a float or an int. And really, it makes perfect sense when you think about it. I mean, what would you do with that imaginary j part? There's just no place to store it in a simple integer.
Hey, before we finish up, here's a quick pro tip for you. Now that you know all about these different number types, you might be thinking, how can I generate some of these for a project? Well, Python doesn't have a single random function built in. Instead, it gives you something way better, a whole module called random that you can import. It's packed with all sorts of tools for generating random numbers. Definitely a great thing to check out next. All right, let's wrap this up with a little quiz to see what you've learned. Here's the question. Which of these is not a legal numeric data type in modern Python? Is it int, long, or float? Got an answer? If you said long, you are absolutely right. Now, this is a bit of a trick question because long used to be a thing in older versions of Python, but now it's been completely merged into int. That's why our standard int can handle those massive unlimited size numbers we talked about. And there you have it, a tour of Python's awesome number toolbox.